Okay, how many masses are being involved? Let's call this one mass 1, this one mass 2. So that means how many equations should I be writing? 4, right? 2 per mass. So let's write the first one for mass 1. Okay, sigma fx. Do you guys want to try it? Before you try it, let me just talk to you about something. How many of you have heard about the bent coordinate systems? But a bent coordinate system is very, very important. You guys get to choose your coordinate system. I have seen so many people make this mistake where they will choose this as a coordinate system here, and then they will choose this for your coordinate system here. Why does this not work? Because when you straighten these out, remember, this is actually a system like this. So what you're saying is that this is like this, and then this coordinate system goes like that. You see it? Yeah. Right? So if this is my x and y, then what I'm saying is that this is my x and y. You see it coming back? It doesn't work. So what we have to do instead is bend our coordinate system, because gods with small g's cannot change coordinate system in the middle of the question. Okay? So when you have a question like this and you choose this as your x and y, this is your x and y, it has to go over and fall down. It has to follow the string down. That is a mistake I have seen even professors make. Even I've made that mistake if I forget and I'm not careful. So how does that affect our question? Well, for mass 1, it will have all our normal ones, normal force up, mg down, m1g down. Do you want to put in friction? Let's put in friction. Be very careful. What direction should friction be? Friction wants to oppose the motion. Where does m1 want to go? Over the string, right? So where should friction be? Excellent. What direction does the mass want to go? And friction will be opposing it. And what direction is tension in? Now look at mass 2. What direction is tension in? And always have mg pointing down. Okay, now let's write the equations. Sigma fx is, well, I have T1 plus, according to my coordinate system, I have Fs minus, why do I call it S? I don't know. I'll call it just friction. So we're not considering pulley friction, because then I have to talk about omegas. I don't want to do that. So it's a frictionless pulley. And what would it be for this? Just N minus mg. Okay, now here's the question. What about equation for mass 2? Should I write sigma fx or sigma fy? And what would it be? Which one should be plus and which one should be minus? Yep. Follow your coordinate system. And there is no equation y for mass 2. This is one mistake we all make at some point in our lives. Follow your coordinate system. The coordinate system tells you what it wants you to do. Also remember, is T1 equals T2? Yeah. Because that's the only possibility. Which means acceleration for mass m should definitely equal acceleration for mass 2. It's angled and bent. Fancy. And all we're doing is we're adding little things. Remember, we always add something very slightly to the question, and it makes it seem like it's gotten to be a really difficult question, but in fact, it's not, right? True. Everything in physics is easy. Once you know how to manipulate your systems, it's easy. Okay, so again, how many masses do we have? Okay, how many equations should we get? Excellent, not 16. 5 billion.
42. Dr. Zain, that's just so on topic.
If I had $5 million, I wouldn't be here right now.
Honestly, same.
Okay.
Not even close.
So now let's look at our system. Here's a trick I'll teach you guys. These questions can get really complicated really fast. Can I tell you a trick? Always use your coordinate system wisely. Why do I say that? I tend always to use my coordinate system along the direction I have power over. G always points down, mg, which means all I have to do is and know that this angle will always be theta. If you choose your coordinate system to go like this, you will have to change every single one of your forces, which is really difficult and a pain. And where will the normal force for this one point? And where is tension?
That way.
And where will friction be?
That way.
And then where will tension 2 be? Up. And mg will be pointing downwards. And where will this coordinate system bend? Over. So again, you will have what? X coming down. N minus m1g cosine theta. And for mass 2, what will we get? Minus T2, yes, plus m2g. And nothing here. Oh, and we should probably have friction in here too, because we added friction, right? Minus friction. What's the possibility of sigma Fy? 0. And this could be MA or 0. And what could this be? Again, MA or 0.